we'll proceed in innovative approach in calculus. Okay, so innovative approach in calculus, we started with Lagrange multiplier. Now we are in partial derivative. I'm sorry, cross, cross Jacobian. So this is what we are saying. There is a full Jacobian, partial Jacobian, and cross Jacobian. Full Jacobian, anyway, it is available. I thought of talking today, kind of, but better we do some exercise. Then we'll come to full Jacobian. That is not our research. But the cross Jacobian is certainly, this is what we have devised. Cross Jacobian is otherwise, it is not available. Cross Jacobian, anyone can see in the book. Cross Jacobian is not available. Cross Jacobian, where it is used. So, in that sense, like if I need to calculate surface area of a sphere, this is what we are pursuing. Surface area of a sphere. How to calculate surface area of a sphere? Okay, I'll get the sphere again. Okay, I believe I have different sphere. This is very big one. And what is the surface area of this sphere? Surface area of the sphere, we know that it is not possible through algebra. Then we came to vector. So we are in arena of vectors now. So algebraic vector. We will see many things in vector. Vector, algebra, calculus, different coordinate system all together. Okay, combination of all together is the future. Okay, if that is the case, then what is the kind of surface area of this sphere? Consider this is a sphere. What is the surface area of this sphere? Okay, then we saw that if I take any point P here, any point P, and then at P, I cut it into XZ plane, I cut it into YZ plane. Now, if I cut it into, don't think that it is like this. It is a sphere, completely round, football. If I take any point on the football, then I cut it into XZ plane and YZ plane. It will result into a circle. So circle in XZ plane, the point P we are talking at any point P, the coordinate of point P is x comma y comma z. Okay, in Cartesian coordinate in 3D, if this is xy plane, this is x-axis, this is y-axis, and this is z-axis. This is xy plane, this is origin. Here it is origin. If that is the case, then z is called dependent upon x-axis and y-axis. X-axis is independent, y-axis is independent. X-axis is not dependent upon y, and y is not dependent upon x, but z is dependent upon x and y both. How it is dependent? Through a function. Z is called function over x and y. Z equal to f small f braces x comma y braces close. Z equal to f x comma y braces close. That is z. Any point on the sphere is x comma y comma z. If that is true, then from origin, if I draw a vector, then position vector of that point P is xi plus yj plus zk. Now we have seen in detail in past two videos that if I take any point P here in xz plane, if I say dp by dx, dp by dx, dp by dx, d position vector by dx. What is dp by dx? P equal to xi plus yj plus zk. dp by dx is I plus dz by dxk. dp by dx will be I plus 0j plus dz by dxk. Can you see dp by dx? If I see the dp by dx, it results into another vector. That vector is I plus dz by dxk. The dp by dx is another vector whose ith component is 1 and kth component is dz by dx. This proves that this vector is in xz plane, I component and z component, I mean k component. So dp by dx is in xz plane, where ith component is always 1, and kth component, the z component, is dz by dx. If I take p on the top, then here dz by dx is 0. If I take on top, then dz by dx is 0. Then what is dp by dx? The position vector. If I change along x-axis, how much position vector would change? What is, sorry, it's very hard. What is what is change in the position? If this is position vector and this is x-axis, then if I move little bit on x-axis, this position vector is changing. How much I see change in position vector when I move 1 unit along x-axis? dp by dx. dp by dx is nothing but I plus dz by dxk. And we know that if I have a position vector and if I calculate that its a derivative, then that will be perpendicular to the position vector. That is tangential at the surface. Anyone can see. So if I say top of, if I have a sphere, I believe I can get another one. It's very heavy. Okay. If I have a sphere, then top of the sphere is here. At top of the sphere, dz by dx will be 0, because there won't be any variation in z as per the x variation, because it is maximum. Then it is I only. I means at that point dp by dx is parallel to the x-axis. Here it will be like, if I go along, then dz by dx will become, it will carry some value. And if I see this end of the sphere, the dz by dx will be infinite. At that time I has no importance. Then dz by dx is, so only z component, kth component is available. Here only ith component is available as far as dp by dx vector is concerned. So dp by dx vector is in xz plane only. What about p? P is xi plus yj plus zk, any point on the sphere, x comma y comma z. dp by dy, that is j, x is gone, j, yj, dy by dy, j, 1, j plus dz by dy, k, j plus dz by dy, k, that exists on yz plane, because j component is there and k component is there. So dp by ds exists in xz component and dp by dy exists in yz component. Now dp by dx is one vector in xz plane and dp by dx is another vector at yz plane. Now at any point, if I calculate dp by dx, that is tangential here, as per the vector we can see, no need to remember anything. It is tangential, right? At the top it is like this, and then slowly it becomes like this, everywhere tangential, and yz plane everywhere. So any moment if I have dp by dx vector, any moment I have dp by dy vector. dp by dy vector, okay, so dp at any moment I have, I have already demonstrated this. So at any moment, okay, any moment this is dp by dx, any moment this is dp by dy. Okay, now there is a plane touching these two lines, dp by dx line, dp by dy line. If I take cross product, it gives me area in between. dp by dx, dp by dy, area in between. Okay, so if I have a vector, we have already seen in the circle how to calculate the how to calculate the perimeter of a circle. If I have a vector like this, if I have a vector like this, okay, vector, tangential vector. If I have a vector like this vector, if I multiply with, if I integrate along x-axis, we will see in separate session y calculating integral of a vector gives the perimeter length. This would be in anyone's mind that if I have a vector along the circumference, vector, not line. If I have a vector along the circumference, or if I have any curve, if I have any curve, and if I have a tangential vector at any point, and this vector is algebraic vector. Algebraic vector means if this is x-axis, what is the difference between algebraic vector and normal vector? If this is x-axis and this is a curve on top of x-axis, algebraic vector means vector's components are algebra that is dependent upon x. Okay, like if I say any point on the circle, any point on the circle, if I talk about position vector, then it is xi plus yj. Then if I calculate gradient of it, then it will be another vector that will be perpendicular to this position vector, and that will be like this. So this is what we are looking for. What is the vector equation of tangential vector? Take position vector, calculate the gradient of it. It will become a tangential vector. So if I have a position vector xi plus yj, then tangential vector would be I plus dy by dx j. Y for the circle is square root of a square minus x square. D of a square root of a square minus x square by dx. That will be minus x divided by square root of a square minus x square. So dy by dp by dx is p is xi plus yj. dp by dx is I minus x by square root of a square minus x square j. Okay, now this vector lies in xy plane. I minus x divided by square root of a square minus x square j. This is the tangential vector equation. Now this tangential vector equation, if I calculate the magnitude of it, then it gives me the algebraic equation of the tangential vector. Why we need algebraic equation? Why we calculate the magnitude of it? I will have a separate session, that innovative calculus. Okay, that is very important to understand why it gives the curve length. Why dy by dx, integration, differentiation, nothing gives the curve length. But if I go in vector form and if I calculate dp by dx, calculate the magnitude and integrate with the dx, you get the curve length. For time being, I believe this is enough. So if I have a dp by dx and if I calculate the magnitude of dp by dx, so dp by dx is also called velocity vector. If p is position vector, that is displacement vector, dp by dx is also called velocity vector. If I have velocity vector, if I integrate with dx, it gives me the displacement. This much is all right for now. So if I have any curve, if I calculate the tangential vector, that is dp by dx, and integrate with dx, okay, it gives me the displacement. Similarly, for the surface, if I have dp by dx, if I have dp by dx and if I integrate along x-axis, then in xz plane, if I cut the sphere, it is a circle, it will give me circumference of the circle. dp by dx and dp by dy. If I calculate the cross product, the moment at which I have taken p, there momentary surface velocity vector it will give. If dp by dx is velocity vector, dp by dy is velocity vector, then dp by dx cross product, because it's a vector, cross product dp by dy will give me surface area, because this vector cross this vector will give me surface area. But that surface area is nothing but, okay, if I consider this as a vector, this is considered as b vector. A vector, b vector, a vector is dp by dx and b vector is dp by dy, then it will be cross product will be surface. But this will be surface area divided by xy plane, because dp by dx is there. It's a velocity vector. So velocity vector cross velocity vector, if it gives surface area, then it is called surface velocity vector. Surface velocity vector into dxy plane will give the net surface, as we got the surface curve length of a circle. dy by dx calculate the magnitude, integrate with dx, it will give the circumference of a circle. Why? We will see in little future. Similarly, if I have dp by dx cross dp by dy, and if I calculate the magnitude, it gives me one value. Integrate with dxy plane, it gives the full surface area. Similar to that. Okay, so dp by dx cross dp by dy, take the magnitude and integrate with dxy plane, that is dx dy, it gives the surface area. Okay, we have seen it is very difficult to proceed on that because dp by dx cross dp by dy is nothing but dz by dx. We have seen dp by dx is I plus dz by dxk. dp by dy is j plus dz by dy k. Cross product will be minus dz by dx minus I minus dz by dy j plus k. Magnitude would be dz by dx whole square plus dz by dy whole square plus 1 square root. Dx dy and integration over the limit will give me the net surface area. But if someone really go along, then it will, and take the example of sphere where x square plus y square plus z square equal to a square, then z is the square root of a square minus x square minus y square. If someone settle it down, dz by dx whole square plus dz by dy whole square plus 1 square root, it will come as a divided by a square root of a square minus x square minus y square dx dy, then integration. Now someone will really feel very trouble in calculating. If I take outside a, then integration of 1 by square root of a square minus x square minus y square dx dy. In this multivariable case, it is very difficult. Then people go for method of substitution. Let x equal to r cos theta, y equal to r sin theta. In that case, someone can substitute it, but dx dy will transform into dxy plane by d theta r plane into d theta r plane. Now dxy plane by d theta r, someone has to calculate the Jacobian, and then whatever comes, then d theta dr, and then method of substitution will. This is very tedious job. First, what we did? First we calculated dp by dx cross dp by dy full, then a square root, then a square and a square root. Then we saw it is not solvable. Then we went to polar coordinate system, and then we changed everything. Then we calculated Jacobian, then started integrating. So cross Jacobian, that is our invention, is if the surface, please watch previous two videos. If surface area calculation is nothing but dp by dx cross dp by dy, magnitude, that is nothing but d surface area by dxy plane, d surface area by dxy plane. If that is the case, multiplied by dxy plane. Now I can go beyond it and I can say multiply it by d theta r by d theta r. If that is the case, then dx dxy plane will go up and it will come as d surface area by d theta r into d theta r. This is our invention. Please do support us. +91 is the India country code. 9483160610. 9483160610 is the telephone number. +91 is the India country code. Now, d surface area by dxy plane into dxy plane. Again, I multiplied with d theta r by d theta r. xy plane gone. D surface area by d theta r plane. If that is the case, if d surface area by dxy plane was dp by dx cross dp by dy, now it becomes dp by d theta cross dp by dr, and whatever comes, then calculate the magnitude of it to calculate the surface area. That is the grammar. Now dp by d theta cross dp by dr. Now we have solved it into a spherical coordinate system where we did not go with theta, we went with theta phi. We did not go with theta r, we went by theta phi. If someone watched the previous video, to calculate the cross Jacobian means if I have xy plane, on top of xy plane I have a surface, spherical surface, and now xy plane, x equal to r cos theta and y equal to r sin theta, then xy plane is not dependent upon theta r plane. So z fxy is dependent upon xy plane. XY plane is dependent upon theta r plane. We're kicking out XY plane completely and making Z or surface directly dependent upon theta r plane. This is cross Jacobian. So dp by cross Jacobian works in vector fundamentals only. So if I have dp by d theta cross dp by dx cross dp by dy and its magnitude is surface area, that is nothing but d surface area by dxy plane into dxy plane into d theta r by d theta r we introduce. Xy plane cut down, now it becomes d surface area by d theta r plane into d theta r plane. So numerator d theta r becomes d theta dr and dxy plane by d theta r becomes dp by d theta cross dp by dr, its magnitude, where p is still in Cartesian coordinate. We have not changed it. So now question is arising. We have solved it through a spherical coordinate system where the variables are theta and phi. The variables are in theta and phi, not r, because if I talk about a spherical coordinate system and spherical coordinate surface area, the surface has constant radius. Radius is not changing. Only theta and phi is changing because there are three independent components in a sphere. One is r, one is theta, and one is phi. Phi is from vertical, it makes phi angle. Theta from horizontal, it makes theta angle. And radius from 0, it go till the surface area of the sphere. So here surface area, if I am calculating, then radius is fixed, that is a, that is radius of the sphere. Theta and phi is variable. Now accordingly we change it to dp by d theta cross dp by d phi, d theta d phi, if someone remembers it. Now question is arising, can I find surface area for the exercise in cylindrical coordinate system? That is a big question. Can someone find surface area in cylindrical coordinate system? Surface area of a sphere in cylindrical coordinate system. Someone really have guts to find it. If I have a, if I have a, if I have a, if I have a sphere, if I have a sphere, can I find the surface area of a sphere in cylindrical coordinate system? So cylindrical coordinate system is typically a cylinder which has a circular base and a height. What are the independent component in cylinder? Cylinder is a 3D. So independent component is theta r, that will go from 0 to radius of the flat circle. There is a circle, on top of it there is a wall, round wall, that is a cylinder. Typical example of a cylinder. Okay, I have a cylinder. No, so I have a cylinder. This is a, this is a cylinder. Okay, so if this is a cylinder, then this guy would sit inside a cylinder. If this is a cylinder, then this guy would be sit inside the cylinder. The cylinder has, it's very heavy. Okay, so this cylinder, if it is sitting on xy plane, if the cylinder is sitting upon xy plane, okay, if the cylinder is sitting upon xy plane, then the it forms a circle here on the xy plane. It forms a circle here on the xy plane, and there is a height. So there is a circle of radius and r and circle, and there is an angle called theta. Theta will go 2 pi, radius will go 0 to a, where height is called z. So if I say volume of a sphere, that is pi r, that is pi r square, that is the surface area into height. Pi r square h is the volume of a cylinder. Now if I place this inside this cylinder, if I place this inside this cylinder, then can I use cylindrical coordinate system to find the surface area of this sphere? That is the question. So how I can find? What we have seen in the past video. What is the variable when I see this talk about surface area of a sphere? So in a spherical coordinate system, theta and phi are two variables. If I say the kind of a spherical coordinate system, if I see the cylindrical coordinate system, then inside this sphere is there. Okay, so if inside this sphere is there, then what about, okay, I had one sphere. Okay, inside this sphere or this sphere I have put. Now, if I see this sphere, consider this sphere is centered at the origin. This sphere is centered at the origin. Centered at the origin means this sphere has two hemispheres. One hemisphere is above xy plane and another hemisphere is below xy plane. This is top hemisphere, this is bottom hemisphere. Xy plane cut at the center. If that is the case, then if I take any height z, if I take any height z from xy plane, then any height z will vary from 0 to radius a in a sphere. Okay, if I take any height z, if I take any height z, then from this is center and this is z, then I can draw a line like this. Okay, if I take any height z, then this is sphere. Sphere is like this. Sphere is like this. Then at any height z, if I take and make a cut, at that point where it is I'm taking a cut, at that point height is z. And from center, if I draw like this, then this is radius of the sphere, that is a. This is z, this is a. Consider at that moment this radius, at the bottom radius is small r. Makes sense, right? If I take a sphere, if I take a sphere and this is the xy plane and top I take z value, then I at z I touch this here. At z height I touch a point here P. From P and the origin inside it, I draw from P and origin inside it, I draw a line. And that length is a, that is radius of the sphere. That height is z, that we saw. That height is variable, but this radius is constant. And bottom length is r. Then that is also variable. Z and r are variable. Then r square plus z square equal to a square. That is the formula. This is also our proof. Please do support us. So a square equal to r square plus z square. Now, if I talk about x component at any moment, now this is like this. If I move like this, theta angle at the beginning, it is like this. If I move theta angle, then it will be like this only. This is r now. This is r. This is r. It becomes like this. Now with angle theta from x-axis. So if that is the case, then r cos theta is x. If that is the case, then r sin theta is y. R cos theta is x. R sin theta is y. Whereas r equal to a square minus z square. Now r is variable. Now if this r is not the base circle radius, that is a only. Because if this sphere is centered at the origin and it is like this and there is a cylinder like this, if there is a sphere, if this is a sphere, then cylinder wall will be like this, vertical. And at the center, if it is centered at the origin on the xy plane, there will be a circle. That circle radius is a, that is radius of the sphere. Everywhere radius a, sphere was sphere. What are we are talking, that is instantaneous radius of a circle, that circle is here. This is the base circle, if I cut it at the center, that circle will have radius a. If I cut it at height z, there is a small circle whose radius is r. That r is variable, height z is variable. If z is 0, that r equal to a. If z is full a, then r is 0. In that sense, I'm taking r as variable and theta as variable to calculate the surface area. R, if z would vary, actually z is variable and theta is variable. Okay, radius r, theta and z, there are three things that is variable in cylindrical coordinate system. Okay, but here this r we are taking as variable. R would vary and theta would vary. Z I am taking out. I'll give it as an assignment that someone should calculate it in Z. Now, if I have dp by d something cross dp by d something, d something, d something. This is the net surface area calculation, where p is in xi plus yj plus zk by something. Now, two variable, I'm taking one as theta and one is r. What is r? Now, everyone understand. If at height z, if I make a cut, that circle radius is r. That r is nothing but someone can think in this perspective also. At this point, if I cut that is height z, then this is the circle we are talking about. Then this is again height z. This is r. Then a z square plus a r square equal to a square. Then r equal to a square. Then z equal to a square root of a square minus r square. Let's take two independent variables theta and r. Okay, z I am kicking out right now. In that case, dp by d theta cross dp by dr. dp by d theta cross dp by dr. Theta r plane we are taking as variable here. Analogous to x and y, dp by d theta cross dp by dr, magnitude d theta dr. What is p here? P is xi plus yj plus zk. If that is the case, then x is r cos theta I plus r sin theta j plus z is nothing but a square root of a square minus r square. A square root of a square minus r square k. Cross product with r cos theta. Cross product. So this is p. P is r cos theta I plus r sin theta j plus a square root of a square minus r square k. dp by d theta, that will come as minus r cos theta minus r sin theta. dp by d theta, if I calculate d theta, it will become minus r sin theta I plus r cos theta j plus 0, because square root of a square minus r square by d theta is 0. Now minus r sin theta I plus r cos theta j cross with another dp by dr, that is cos theta I plus sin theta j, r is gone, minus r by a square root of a square minus r square k. If I do cross product of these two vectors, then it is minus a sin square theta minus a I will cross with j and k. So minus a sin theta will cross with sin theta minus r sin square theta. I and j cross means k minus r sin square theta k. Okay, and then I and k cross will be minus j, I believe. I and k cross will be minus j. That will be minus j, minus plus. That will be a sin r sin theta into r divided by square root of a square minus r square. Okay, it will become r square sin theta divided by square root of a square minus r square j. Okay, now second term, that is r cos theta. r cos theta. R cos theta is j term. So j and I will be minus k. So r cos square minus r cos square k. Here minus r sin square k is there, minus r cos square k. This will settle down as minus r square. So minus r square k came into the picture. Minus r square k plus r square sin theta by square root of a square minus r square. Now j cross will go away, and now j and k cross will result in I. That is that is here it is r cos theta. So r square cos theta divided by square root of a square minus r square. So full terminology is minus r square k minus r square k minus r square k, and then r square sine theta divided by square root of a square minus r square j j, and then r r r r square cos theta divided by square root of a square minus r square I. Now I have to calculate magnitude of it. So I'll do a square of all these three and a square root. So first term is, I remember, it is r. Okay, first term is r, single r. This is what I remember, single r. Then it becomes r square, r square. Another is r square cos theta divided by a square root of a square minus r square. One is r square sine theta divided by square root of a square minus r square. So it will become r square plus r to the power 4 cos theta divided by a square minus r square plus r to the power 4 sine square theta divided by a square minus r square. If I settle down these two, it becomes r to the power 4 by a square minus r square. So square root of a square plus a to the power r to the power 4 divided by a square minus r square. Now r square I can keep outside. Then it becomes r. A square root of, if I settle it down, it becomes a square minus r square minus a square minus r square plus r square divided by a square minus r square square root. This, if I again settle it down, it becomes a divided by square root of a square minus r square. A, if I keep outside, it becomes r by square root of a square minus r square. R by square root of a square minus r square dr d theta. What is integration of r by square root of a square minus r square? Minus square root of a square minus r square. R by square root of a square minus r square integration is minus square root of a square minus r square dr. Dr is done d theta. Now limit for the sphere, limit r will vary from 0, that we have seen. 0 will become when z is a, and when z is 0, r will be a. So r will vary from 0 to a, 0 to a, theta 0 to 2 pi. Now minus the square root of a square minus r square, r is 0 to a. If I put a, it is 0. If I put 0, minus outside will go away, it will be a. Okay, a I have kept outside, a square. And d theta is theta 2 pi. 2 pi a square is the surface area of a sphere. But if you remember, I calculated top hemisphere only because I had centered the sphere at the origin. So 4 pi a square to cross Jacobian, how simple it is. Directly we converted the dp by dx cross dp by dy magnitude and then dx dy, then calculated, then sorry, it is very difficult. Then I went to theta. Why I went to theta, that also I don't know. Then reconverted it, rephrased it, then we did. Directly we are doing cross Jacobian, directly dp by d theta, dp by di, directly. Calculate in the, without any pen and paper I can calculate. Trust me, I have not used pen and paper here also. Anyway, it's not that I have practiced and I'm talking like this. And now it came as pi 2 pi a square, full 4 pi a square. Now what is the assignment here now? Assignment is that instead of making variable theta and r, make variable theta and z, where a, r we will keep as outside. If that is the case, then dp by d theta cross dp by dz, d theta dz. dp by d theta cross dp by dz, magnitude d theta dz will be the surface area of a sphere. Okay, if that is the case, then what is p? Xi plus yj plus zk. X is r cos theta, where x is r cos theta and y is r sin theta. R is nothing but a square root of a square minus z square. So square root of a square minus z square cos theta I plus square root of a square minus z square sin theta j plus zk, simple zk, dp by d theta square root of a square minus z square minus sine theta I plus square root of a square minus z square cos theta j plus 0. And that side it is square root of a square minus z square, that will come as minus z by divided by square root of a square minus z square I by, okay, cos theta I minus z by, okay, by dz we are doing, right, dp by d theta cross dp by dz, dp by d theta it is square root of a square minus z square minus sine theta I, okay, plus square root of a square minus z square cos theta j plus 0. Another is dp by dz, that is minus z by square root of a square minus z square cos theta I minus z by square root of a square minus z square sine theta j plus 1 plus 1. Now cross product of these two. So first cross product is square root of a square minus z square minus sine theta with minus z square root of a square minus z square. Okay, I will go away. So I cross product cannot happen. So another is minus z by square root of a square minus z square cos theta. So here, okay, I'm sorry, sine theta. So here minus sine theta, sine theta. So minus, and then minus is already there. Minus minus plus, and it will become something like square root of a square z square will go away, something like that, and it will become z z sine square theta, something like that, z sine square theta, and then last term will become square root of a square minus z square minus sine theta, because that is 1. Okay, similarly second term if I do, then it will become like z cos square theta, z cos square theta, and last term will become like whatever it is, square root of a square minus z square cos theta. Now if I settle it down, one is z sine square theta, one is z cos square theta, that is z, that is pure z. And next is square root of, I'm not taking care of minus minus because I'll do a square now. The one is z and another is, now if I see, then it is square root of a square minus z square cos theta. Another is square root of a square minus z square sine theta. If I do a square, then cos square theta plus sine square theta will go away. Now it will become now z square plus a square minus z square. Z gone. I have never tried it. Square a square square root a dz d theta or something like that. I don't know. A dz d theta. Simple, right? Now if I integrate dz, that is from 0 to a, then it becomes a square. D theta becomes 2 pi. 2 pi a square, that is top hemisphere. 4 pi a square. So through, please do support us. Plus 91 is the India country code 94831600610. Calculus is really amazing. So we can calculate the surface area through cross Jacobian. So quickly we found, right? So quickly. This is power of cross Jacobian. So make z bar dependent upon xy plane, force z to depend upon new independent variable. So xy plane is dependent upon here theta z plane, In earlier case theta r plane. Make z dependent directly upon theta z or theta r plane. Kick out x, dp by d theta cross dp by dz or dp by d theta cross dp by dr. Calculate the magnitude and d theta dr or d theta dz. Settle it down and you get it. We will see one more session, I believe. Then we will see the power of vector, power of algebraic vector. So please do support us, it helps.